In this video, we're going to talk about quadratic functions and get an idea of some basic features of them. So, our quadratic function is of the form ax squared plus bx plus c. And what really makes it quadratic is this term with x squared. So really, this bx could turn into 0, c could turn into 0, but we need x squared in there because that's what makes it quadratic, that exponent of 2 on our variable x. So you'll see at the end here, this a cannot equal 0, and it's because that term can't be wiped out, but the other two could. So we have these numbers, this a, b, and c. When we have our function, those will be real numbers, positive or negative, coming through. And with a, that can tell us the shape of our graph. So with quadratic functions, when we graph them, we're going to have something called a parabola. And there's two ways this parabola can go. It can be opening upwards, or it could be opening downwards. So depending on a, if a is positive, then the parabola is going to open upward. If a is negative, it's opening downwards. So if we look at a and just evaluate the sign that we're seeing, it'll give us an idea of the direction that the parabola is going in. The vertex is the turning point. So like with the parabola opening upward, there's this kind of minimum point coming through, and that would be a vertex xy. For the parabola opening downward, it comes through as a maximum value, but that would be some vertex xy. So it's a turning point, and then depending on whether our parabola is opening upward or downward, it comes through as a minimum or a maximum. The axis of symmetry goes through the vertex. So the axis of symmetry is this kind of invisible line, and the parabola is symmetric across that vertical line that I just drew there. So going through the vertex, it's cutting our parabola in half. So what's happening on the right-hand side is also happening on the left-hand side. The y-intercept occurs where the graph crosses the y-axis. So when we have our x and y axes and we draw our parabola, so let's say I draw something like this, wherever we cross that y-axis, that's going to be our y-intercept. So that's where x equals 0. And in fact, we can even grab this. Our y-intercept is going to be equal to that value of c coming from the ax squared plus bx plus c, because if we plugged in 0 for x, ax squared would wipe out, bx would wipe out, and all we'd have left over is c. So the y-intercept comes from the coordinate 0, c. The x-intercept, or intercepts, are where we cross the x-axis. And there are some different scenarios for how this can occur. We can have two x-intercepts. We could have one x-intercept, so that would be where our graph goes and just touches the x-axis, so the vertex would be on the x-axis. We could also have a case of no x-intercepts. So let's say I have a parabola opening upward and it's above the x-axis. That's still a parabola, it just never crosses the x-axis. So that would be no x-intercepts. So these are the three cases we could see. No x-intercepts, one x-intercept, or two x-intercepts where we cross both places. And our last piece here, the vertex. We can calculate the vertex, so using this ax squared plus bx plus c form. And what we do is we start with the x-coordinate. The x-coordinate is calculated by taking negative b over 2 times a. And then once we get that x-coordinate, what we would do is plug in that value into our function, and that would give us our y-coordinate. All right, lots of information there, so let's get some practice with putting these together. But the idea is that we want to be able to be given a function and get a pretty good sketch going for what the function looks like on our graph. Okay, so answer the following questions using the function f of x equals x squared minus bx plus 8. Sorry, x squared minus 6x plus 8. Started translating to a, b, and c in my head before we did it. So with this one, a is positive 1, b is negative 6, and c is positive 8. So the first question, does the parabola open upward or downward? So if a is a positive 1, that means our parabola opens upward. So if I draw the parabola, it dips down and goes back up. What is the vertex? So what we're going to do is use that negative b over 2a to calculate the x-coordinate. So x equals, so negative b, so negative, and then for b, I'm going to use parentheses and put in that value of b is negative 6. All over 2 times a, which would be a 2 times positive 1. So in that numerator, I have negative negative 6, so that's a positive 6. And then divided by 2 times 1. So I'm getting x equals 3 here. So that's my x-coordinate. Then to find the y-coordinate, what I'm going to do is evaluate f of 3. So plugging 3 into our function, so we'll have 3 squared minus 6 times 3 plus 8, which is 9 minus 18 plus 8, which is a negative 9 plus 8, so a negative 1. So the vertex is an xy coordinate where x is 3 and y is negative 1. So if we started making a graph right now, I would have a coordinate to graph. I know where the vertex is, and then I know the general shape would be going upward from that point. The axis of symmetry is a vertical line. So with that, we're going to describe it as x equals. And it's going to come from the x-coordinate of our vertex, because that axis of symmetry, it's that vertex is always halfway between where we're increasing and decreasing on our graph there. So all I'm going to do is grab that x-coordinate of the vertex we just found. So x equals 3 would be this vertical line. That would be the axis of symmetry. Finding the y-intercept. So this is where we look at x equals 0. So if we evaluate f of 0, so we have 0 squared minus 6 times 0 plus 8. Like I was saying up above, we're just going to be left over with that value of c, which in this case is a positive 8. So we have a y-intercept of 0, 8. And then for the x-intercepts. So this is where y equals 0, or where, in this case, f of x equals 0. So what I'm going to do is plug in 0 on the other side of the equation. So we're going to have 0 equals x squared minus 6x plus 8. And what I want to do is solve this. So at the beginning of the term, we had some factoring review. And that assignment's open up for review if you need to go back to it. But this section with quadratics and when we go to polynomials, we're going to need factoring. So if you need to review any of that, you can go back and check out those videos, because I'm just going to kind of go through the motions with these. So 0 equals, I'm going to factor this. So I want two things that multiply to positive 8 and add up to a negative 6, and that's going to be a negative 2 and negative 4. So I multiply those, I'll get positive 8, and then negative 4x plus a negative 2x would give me that negative 6x. All right, so then factoring helps me split that apart, but then I'm going into this concept of solving quadratic equations. So I'm just making notes here in case you want to look up other videos on these. But I'll review this topic since we didn't do too much with solving. So solving quadratic equations, what I have are two things that are multiplying together that equal 0, and to multiply two things to get 0 out. Like if I had a times b equals 0, what that tells me is that a has to equal 0 or b has to equal 0. It's just a very specific property of multiplying to 0. So I'm trying to think of the name of the rule is product of zeros rule. This is the product of zeros rule. So if we have things multiplying to equal 0, then at least one of those pieces has to equal 0. So if I have 0 equals x minus 2 times x minus 4, that means that x minus 2 has to equal 0 or x minus 4 has to equal 0. And then I would solve these separate equations. So I'd have x equals a positive 2 and x equals a positive 4. So this is all defined the x-intercepts of the graph. So what we just did is we set y equal to 0 and solved for x. So we have this coordinate, x is 2, y is 0, and we have a second coordinate of x is 4 and y is 0. So with all of this, I can get a pretty good sketch going. In fact, let's go ahead and just do that. I'm just gonna go, let's see. Sorry, I'm thinking about the coordinates. I'm gonna go 1, 2, 3, 4, 5, 6, 7, 8, 9 on the y-axis, and then I'll go down 2. And then how about a 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 along the x-axis. Okay, so we found a vertex at 3, -1. So there's 3, -1. Just found two coordinates, 2, 0 and 4, 0. And those work nicely as being, like, again, that vertex is setting this axis of symmetry. So seeing those points working together, we have this nice symmetry going. We also have that coordinate 0, 8. So 1, 2, 3, 4, 5, 6, 7, 8. And we know it's opening upwards, so that's matching here too. And basically, if I connect those dots with a smooth curve, we're looking pretty good. So we get a decent sketch out of that with those coordinates.